Finally, I'm going to show you how we model this in the calculator. So here it says this table over on our right shows the town's population. Year 1 refers to 2001 and so on. Now create a scatter plot of data and determine the type of polynomial function that can represent the data. So here, I'm going to type this in. I want you to know we never type in years as like 2001, 2002. You never do it like that. You always start with year. The first year is year 1. So I'm going to go over to my calculator and I'm going to start typing this in and then I'm going to pause it so you don't get carried away. So I go to list and spreadsheets. The first thing I need to do is I need to label my X column and my Y column. The calculator will not know what to do if you don't tell it which variables are what. So I'm going to say year 1, it had, if I remember right, it was 5,500, or no, 5,050 people, I believe. Yep, and now I'm going to go all the way down and type in this list. I'll unpause here in a second. All right, I now got the data typed in. So here's how you add a scatter plot if you remember. You press Control Doc. This is going to add a page. We're going to go to Data and Statistics. Now once you click on that, these are those random scatter points that we have, but we have to tell the calculator which axis is which. So this is, we choose the variable X that we labeled, and this will be the variable Y. And you can see the point. Now this has, it looks like 1 turn, 2 turns, and a 3rd term. So to me, this has to be at least quartic. All right? So what we do now is we come up with a regression. Now to do a regression, you go Menu, Analyze, Regression. And I'm going to click Show Quartic. All right? And now there's this long equation out here. All right? Now, if that was hard to see, what does this resemble? I can't tell. Here's one thing you can do. And plus, you can't even really see that equation. You can go back over to the first graph we have, and from here do our regression. So we go Stats, Stat Calculations, and we're going to choose Quartic Regression. You type X for X list, Y for Y list, and you press Enter. Now when this comes up, it shows this number R squared. What makes a good fit is if R squared is really close to the number 1. As you can see, this is really, really close. So let me show, let's say one that's what this graph is not. This, when we look at it, it definitely isn't cubic, because remember, cubic would go, if it was traveling this way, it would need to come up and finish this way. So let's go type in cubic and see what we get. So I'm going to come over here, and I don't want to copy over these values, so I'll do it from this side. And I'm going to do Menu, Statistics, Stat Calculations, and choose a cubic regression, because this would be a wrong regression. I'll type X in here, Y in there again. Now we know it's not this, but when I do R squared this time, I get 0.89. Now some might argue that that's still a good value, but this is much better. This R squared is closer to 1. So we know this is cubic, and this would be our equation that it gave us up here. All of this would be, this is your A term, B term, C term, D term, and E term. Because it's quartic, there are 5 terms. Just think about how a quadratic has 3. Each one has 1 more than the power. So those would be the values. Okay, so I just wrote out everything here. You can pause the video if you need it. We entered our data in list and spreadsheets. We looked at the picture, thought it was quartic. We checked by going back to list and spreadsheets, and we checked the R squared. So that's how we did all that. Now I'm going to skip over and do part B. It says write a polynomial function to model the data. And so we can round each coefficient to the nearest thousandth and then state the correlation efficient. All right, so let's look at this. What I've done is I hit Control Doc again to get a new graph or a new document. I'm going to hit Add Graph. So I still have all these others up here. But when I add a graph, this time I can get my equations. Now we said it was not the cubic, it's the quartic. So I'm going to pull up that equation, press Enter. Now this is the equation I want, which it's hard to see the whole thing. It's kind of a shame. Let me press Tab and see how much we can get. So nearest thousandth would be negative 5.311 x to the 4th. And we can go on down the list. For the sake of time, I'm going to just copy over the values. And I'm going to use these values from over here. I think I'll get them a lot easier. So I'm actually going to pull from the table. And I'll paste them and then pull back from the, I'll start the video again. And here's your equation. Isn't that a crazy equation? But that would model that data and model it pretty well. The last part. It says use the model to estimate the population of the town in the year 2012. So that's year 12. Here's how we're going to go back to that. I'm going to go to the graph that we had. And I'm going to just press Control T. So I have the equation, and I'm going to go down to year 12. And this would be the estimate for the population, which we can see it's not a very good estimate there. And so this would not be a good model for that. And now we could also go back and figure out which represents this population. And so if we need to find when it's 10,712, what you can do is come over here to our graph, and I'm going to take away the table by pressing Control T, and I'm going to press Tab and look for, I'm going to put in a number here, 10, for the third equation, 10, 7, 12. Press Enter. And now I'm going to look for the intersection of these two. Now, according to this, it doesn't look like they ever hit each other. So when I go Menu, Analyze, I would do an intersection, and I would look for those, and it doesn't hit. So again, this is not a good model for this population. And we can see why is because if originally the graph gained in population, but then it started losing population. So it never gets up to 10,000.